Welcome to lecture number 18, and we have been discussing about two simple tests. Performing those two tests, one can determine the equivalent circuit of a transformer. For example, you first do the open circuit test, and open circuit test is carried out from the LV side, and you will be, if you call the LV side as 1, then you will be getting this RCL 1 and XM 1. Similarly, of course, I have not told you why it should be done on from the LV side, that I will discuss today. And then if you carry out the short circuit test, better carry it out from the HV side, the reason we will discuss. But if it is carried out from the HV side, then what parameters you will get is RE2 and XE2, and the calculations are pretty simple. In this case, the wattmeter reading, then approximately records the copper loss. Core loss can be neglected. During short circuit test, somewhere I write during SC test, core loss, it takes place, no doubt, is much smaller than copper loss. Iron loss, sometimes core loss is also called iron loss. Whatever it is much smaller. So, that can be neglected, and we say the wattmeter reads the copper loss only. And this saying in language, in the equivalent circuit, it means you can neglect this branch. Both magnetizing current can be neglected, as well as core loss component of current can be neglected, whatever power is drawn. That wattmeter reads real power only, real power loss will take place here in RE2, ISC square RE2 and VSC by IC from JD2, these two can be found out. So, now we have carried out two tests, but my final objective is to draw the equivalent circuit, refer to a particular side. Refer to which side? It is my choice, the user's choice. He decides, okay, with respect to side 1, I want to draw the equivalent circuit, or somebody else would like to draw the equivalent circuit, refer to the secondary side. But nonetheless, whichever side you draw, your end results will come same. So, you need not worry about this side. Okay, you choose a side with respect to. Now, after doing this test, you see that I just draw here LV side. From LV side, I carried out the OC test, and whatever values you have got in the open circuit test, this is HV side was open. You got RCL1, the parallel branch, and XM1, these two values I got. And while doing short circuit test, which I told you for reasons not yet told, that you suppose carry out the short circuit test from the HV side, and during short circuit test you keep it shorted. So, you are looking at the equivalent circuit referred to this side, then you will be getting RE2 and XE2. Therefore, to draw now, I want to draw the equivalent circuit. To draw the equivalent circuit, refer to, and suppose LV side I am calling it side 1, HV side calling it side 2. So, this is 1, this is 2. So, to draw the equivalent circuit, refer to LV side, it should be drawn like this now, V 1 rated voltage you will apply, and approximate equivalent circuit I am telling. This is RCL1 and this is XM1 parallel, and these values are already known. So, I will put these values, and then I have to that series impedance, which I know it must be RE1 and XE1, but from short circuit test I have got RE2 and XE2. So, do not put RE2 XE2 here, then that will be a blunder. So, now you have a duty to change this RE2 to RE1 and XE2 to XE1, and that can be easily done since RE2 and XE2 is known. Turns ratio from the rating of the transformer I know it is N1 by N2. RE2 with respect to side 2 it is known. Therefore, this RE1 should be, so RE1 where RE1 should be equal to A square into RE2, where A is this turns ratio N1 by N2, N1 by N2, and RE2 is equal to A square into XE2. This you have to do, then put it here. So, these values should be transformed correctly, then write it here. This is the equivalent circuit. What should I write? Should I write V2 here? No, I should write V2 dashed, and so on. Then wherever this circuit is now connected, I can replace that transformer by this equivalent circuit and calculate all the things needed. Similarly, this test although has been done from LV side and HV side to draw the equivalent circuit. So, once you know this, then you know equivalent circuit referred to HV side will simply be this one. Structure remains same here. With respect to HV side, then you should write here RE2 XE2, do not disturb them, because that is with respect to HV side, those parameters are known. But only thing, then do not write here RCL1, you should write RCL2 and XM2. And what is RCL2? It should be RCL1 by A square and XM2 as XM1 by A square. Therefore, you can do the test either from LV side or HV side, then you can of course draw the equivalent circuit, refer to any side you like, but you should be careful about these 2 points. Now, I will tell you why people say that generally you carry out the LV test from the short circuit test from the LV side and open circuit test from the LV side and short circuit test from the HV side. The reason is rather more practical than saying that it cannot be done. I mean, for example, in this transformer, the rating of the transformer, I chose to clarify some of the points. Suppose the rating of the transformer is our this transformer 200 volt stroke 100 volt 50 hertz single phase and kVA rating is suppose 1 kVA. And as I told you, the rated current of this side is 5 ampere and this side is 10 ampere. And these numbers you can easily calculate straight away. Once a problem is given, be ready with these numbers, what are the rated currents of these two sides. Now, for this transformer of this kind of rating, there is really no restriction, because in the laboratory these voltages are low voltages and available in the lab. One should not make a issue or insist that for this transformer you carry out the test from OC test from the LV side and SC test from the HV side. Reason is simple, these two voltages are available in the lab. We can always get these two voltages of 50 hertz. Using a transformer, auto transformer, always you can connect to get these voltages. Similarly, these current values are also reasonable values, 5 ampere, 10 ampere is no large values at all, no issues. You can have wattmeters of these ranges. Therefore, if you carry out the open circuit test from the HV side, you can do it. What is wrong? So, for this kind of transformer of this kind of rating, no restriction on carrying out a test from a particular side. Remember, let us come to the circuit diagram of open circuit test. It needs some telling. Open circuit test. Suppose the rating of the transformer is this, it is written there, okay, fine. Now, if I carried out the test, open circuit test for this transformer from the high voltage side, I have to apply rated voltage 200 volt 50 hertz is available. I will apply that. Rated current of the HV side is 5 ampere only, is not? HV side is 5 ampere. So, its no load current will be small, okay, but meters are available to record that. Similarly, wattmeter with rating 200 volt and that current rating estimated current is 2 to 5%. I can easily carry out the test either from this side or then that side, no problem at all in the laboratory, because all the ranges of the meters are available and so on, and no safety issues also, is not. Now, similarly, during short circuit test, if you had carried out the short circuit test energizing from the LV side, keeping the HV side shorted, also for this transformer no issue, because rated current is only 5 ampere and 10 ampere. LV side you can do, you will. So, all the voltages and currents to be measured, power to be measured are all those meters are available and there is nothing wrong in that. But you imagine, suppose I say you that I have to test a transformer, I ask you to find out the rating of a transformer whose rating is 100 kVA. I am just taking some 100 kVA, then say 1000 volt stroke 100 volt, 50 hertz transformer. single phase. This is the transformer whose parameters I want to find out. Suppose somebody says that okay, I will carry out the open circuit test. He suppose thinks that open circuit test from the HV side, OC from HV side. Suppose somebody decides, can I not do it? Open circuit test demands that whichever side you energize, you have to apply rated voltage, because you have to create rated flux. So, all the core loss should take place. Therefore, suppose somebody, this is the HV side and LV side he keeps open circuit. So, he has to apply 1000 volt here, and he has to connect an ammeter and an wattmeter and a voltmeter. First thing is to carry out the open circuit test from the HV side in the laboratory, you then require a 1000 volt. 1000 volt is not easily available, although perhaps 200 volt is available, connect another transformer, get 1000 volt, that is also not a big issue. But the point is, whoever will be doing this experiment, his safety will be in question. On the table of this equipments you have kept, you will switch on 1000 volt supply, 1000 volt supply is dangerous in the laboratory. You cannot work unless it is a high voltage laboratory specially designed. Therefore, immediately you see to apply rated voltage, I come and say you no, do not do this, there will be a big safety issue, you cannot apply. So, open circuit test carrying out from the HV side, that is why people in general say okay, carry out the open circuit test from the LV side. Understood. So, 1000 volt you cannot apply. Similarly, also you see then you will require a pressure coil whose rating is 1000 volt. Current coil rating of course will not be a big problem, because what is the rated current? As I told you, given a rating of the transformer of this kind, what is rated current of this side? IHV rated is how much? 100 kVA divided by IHV rated is how much? It is 100 into 10 to the power 3 volt ampere divided by 1000, is not? So, 100 ampere. What will be ILV rated? ILV rated will be how much? LV side rated current will be higher. What is the turns ratio? 10. So, 10 times higher, 1000 ampere. Getting? Now, therefore, you see I am doing the test, trying to doing the test from the HV side, then I see IHV rated is this one. What will be the order of no load current? About say 5%. So, 5% of 100 ampere into 0.05 is how much? 5 ampere. Therefore, the current drawn will be less, that ammeter I can have. Similarly, current coil of the wattmeter will not be an issue from the HV side, but the voltage is high, which is dangerous for the personnel who will be carrying out the test. So, this should not be carried out from the HV side, but from the LV side if you do, what during open circuit test, how much voltage you need to apply? 100 volt only, very safe, available voltage in the lab. What will be the pressure coil of the wattmeter? 100 volt. What will be the order of the no load current? 1000 into 0.05, say 5% of this one. How much it is? 50, is not for this particular transformer. So, 5% of this is 50 ampere. Okay, 50 ampere large current, voltage is not high. So, I can use CTPT or ammeters of measuring a 50 ampere is available, do not worry. Even if it is not available, I can use CT to scale down the current. Pressure coil, no issue. Therefore, it is this thing you do LV side. So, for large transformer with ratio of turns ratio are very large, then really it becomes an issue, high voltage. So, carry out OC test from LV side, always LV side. Now, what about SC test? Short circuit test, people say carry out from the HV side. Why? Because during short circuit test, you know, you will be, suppose somebody says no, I will carry out the short circuit test from the LV side. If you want to carry out the short circuit test from the LV side, what are the things you require? What are the meters you require? LV side, suppose you require ammeter, you require wattmeter and a voltmeter. Suppose from the LV side, how much voltage you will be needing? What is the LV side? 100 volt, very little voltage is needed, that is not a big issue. With an auto transformer, not 100 volt you apply, and HV side is shorted. Is not, HV side is short, but what is the rated current? Rated current is 1000 ampere. So, you have to measure that current 1000 ampere range. Ammeter may not be so easily available, or of course, you can use CTPT, and voltage rating is small. Similarly, the current coil of the wattmeter should be of the rating of the same. In the laboratory, such a wattmeter may not be available. Therefore, all this point to the fact, but if this was HV side and this was LV side, you see high voltage side, what is the rating? 1000 volt. But you require do not require 1000 volt to carry out SC test, only little voltage, maybe 10% of that, which will circulate the rated current. So, 100 volt, maybe 150 volt, etc. And the current will be also small, rated current is only 100 ampere. So, these are the issues why people say carry out for transformer with large transformer, high KVA rating, large voltage ratings. If voltages ratios are one side is kV, another side is volt. For example, distribution transformer 6.6 kV, of course, those are 3 phase transformer, but 6.6 kV and 440 volt. This is the kind of transformation ratios. In that case, to carry out the open circuit test, you carry it out from the LV side, and similarly to carry out the short circuit test, carry it out from the HV side, and generally this is the statement. Of course, since it is expected you will carry out the test from 2 different sides, therefore, at the end after getting the parameters, parallel branch parameters referred to the LV side and equivalent series impedance parameters, which you will get from the short circuit test carried out from the HV side, then you stop, you think a bit before drawing the equivalent circuit refer to a particular side, you have to do a little bit of transformation, either that parameter or this parameter, depending upon from which side you want to draw the equivalent circuit of a transformer. So, that is the there are a lot of examples, consult any machine book. I have not yet told any machine books names yet, I will tell you somewhat later. I will insist that first go through the lectures and whatever study materials I give you go through that, then I will give you names of some books. There are so many books, good books are there. Open the chapter equivalent circuit, see the data of open circuit test and short circuit test. On your own, try to find out the equivalent circuit parameters. Only one comments about these two testing. See, two comments. Two or one. Anyway, let us see whether two comments can be made. What I am telling, note that during open circuit test, no matter from which side you do theoretically, transformer will have core loss only, practically core loss only, is not, because copper loss is neglected, only little current is drawn. And during short circuit test, transformer will have only copper loss only. I have put this symbol to indicate that okay, little bit of core loss, copper loss will be there, here also core loss will be there. Why? Because during open circuit test, rated flux, rated flux means rated flux density. Rated flux density means core loss will be at its rated value, and we will have only copper loss during short circuit test, because flux is much smaller than rated value. Why? Because you require very little voltage to carry out short circuit test, and it is copper loss only. Therefore, if you take a transformer and while carrying out these two tests, we find this is the situation. But certainly, you have purchased a transformer, for example, the same old good old transformer I am always referring for easy calculation, 1 kVA etcetera. Rated current is 5 ampere, rated current is 10 ampere, 50 hertz etcetera is there. Now, you have purchased a transformer, you do the open circuit short circuit test, but you will be putting this to use na, so that transformer is fully loaded, it should operate under full load condition. For example, you would like to see transformer, this transformer in operation, what will be this situation? In operation, situation will be you apply 200 volt here, approximately you will get 100 volt there, and you will connect an impedance here. So, that you have purchased 1 kVA transformer, you would always like to see the transformer operates under full load condition. So, you must apply rated voltage, get almost rated voltage on the secondary side, voltage across this terminal may be little less, that is okay, we will see that. But what I am telling, for normal operation I would like to see this side carries 10 ampere current, this side carries current 5 ampere, and you will be happy, because based on that only you have purchased a transformer. You have not purchased a transformer to carry out open circuit and short circuit test, that is there to find out the parameters. But you have purchased this transformer, you know you have to supply a load at 100 volt 10 ampere current. So, this transformer should be put to use under this condition. Applied voltages are on this side, that side rated voltage, and windings are also rated current. Then only you are really utilizing the transformer properly. This is the transformer in operation. You would like to have this situation prevailing. You have spent so much money to install this transformer to supply the load. Certainly not, you have connected a transformer and supplying a load which is 2 ampere secondary. What is the fun? Then why you have purchased a transformer of secondary current rating 10 ampere? So, this will be the situation. We would like to see, okay, this thing happens, you will be happy, oh, transformer is now fully utilized, and it is called rated condition. Windings are carrying rated current, and also, so in this case, transformer in operation under full load condition, I will be very happy. Oh, so the flux is rated, as well as copper loss is also rated, because windings are carrying rated current, is not. Both these losses, unlike open circuit and short circuit test, during open circuit test only core loss rated value, during short circuit test only copper loss at rated value. But when the transformer will be in operation, both these losses will be at its rated values. You must understand this. So, both the losses are at their rated values. So, if I ask you a simple question that open circuit test, there is power loss, temperature will rise. There will be some temperature rise in open circuit test. There will be some temperature rise during short circuit test. You measure them, okay. This is the maybe 30 degree is the temperature, some number I am just telling. Here it is suppose 35 degree copper loss. But when the transformer will be operating at rated voltages and also windings are carrying rated current, that is what I would like to happen. I would like to see this thing happens, then only I will be satisfying myself. I purchased a transformer of this rating whose windings can carry rated current 10 ampere, 5 ampere, voltages can have 200, 100 volt. Under this condition only I would like to see the transformer is operating. But when the transformer will be operating under this condition, both these losses will be present and temperature rise will be much higher than this under these two conditions. Anyway, this you just note, we will refer to this information later in the next class. Thank you.